Welcome to solverfy.
All right, so here we're writing some pseudocode for the extended GCD. So I'll just call it extended GCD, and we need what we're taking the GCD of, right? So it'll just be A, B, which are positive integers. Okay, so first we just want to set all of our initial conditions, right? So the algorithm just states that S naught is equal to 1, S1 should be equal to 0, T naught should be equal to 0, and T1 should be equal to 1. Okay, we'll also just set X equal to A, Y is equal to our B, and then we'll have a little index here as well. So a lot of just setting our variables. Okay, so then we move on and we want to make a while loop. And this loop is going to do that first case where we find all of our Q's essentially, right? Where we are going through and doing our division. So while y does not equal 0, we'll take the remainder of x mod y. We'll let qi be equal to x divided by y. Then we'll set x equal to y and y equal to r. So that's the case where, if we were taking the GCD of 144 and 89, we would get 144 is equal to 1 times 89 plus 55. But then we're setting x equal to y. So now that next time we'll take 89 and figure out what that is, where y is the remainder, 55. So here we're sliding those numbers into their new roles, and then we're indexing plus 1. Okay, so we're going to do that all the way down until we get a remainder of 0. Okay, and so that will give us our nice list of QIs that we need. So once we've gone through and figured out all the quotients and remainders, then we'll say, well, for j equal 2, and so this is indexing because we've already set our s and t's for the 0 and first index. So we start at 2, 2i minus 1. Now we'll just do our algorithm equation, right? So we'll set sj is equal to s of j minus 2 minus qj minus 1 times sj minus 1, and we'll set our t of j the same way. We're really just replacing the s's with t's here. So q of j minus 1 times s subscript j minus 1. Okay, and so then that'll go through and we get our list of s and t's all the way until there are no more. And so now we can return the GCD of AB, which is going to be equal to Sn of A plus Tn of B.